Alright, so last section of the year, 7-5. Parts of similar triangles. So we're going to throw a lot of stuff together that we've learned before, or maybe we've seen in homework before, but haven't made that connection yet. And oh, by the way, make sure that you do not miss the first day of school in January. It's probably one of your most difficult lessons of the year, so don't miss school, or you will be very sorry. Not nice of me that I hit that with you the first day coming back. It can't be helped. Okay, so Theorem 7.7 just says that if two triangles are similar, so if you're told they're similar, then the perimeters are proportional to the measures of any of the corresponding sides. So I've put here, obviously to find perimeter you add up each of the sides. So those perimeters are proportional. And I could use now perimeter in my ratio with any set of corresponding sides. So you're going to find that handy. So let's look at example 1. You have to draw a picture to go with this. So it says in the figure below. So here's your figure. You cannot assume that this is a right triangle unless you're told. Some of you were assuming that on your quiz that you took. And then I'm going to give you the following information. From A to C is 31. And then from C to D is 23. And then from A to D is 16. So we know all three sides of the big triangle. Then we have these two smaller triangles inside the big one. And for right now, this is all I know. So the question says, find the perimeter of ABD. So we're finding the perimeter of this right here. And they say that triangle ABD is similar to triangle ADC. In this similarity statement, they're telling you what angles correspond to each other. Don't the two triangles overlap at angle A? Right? And so then they're also telling you that B and D correspond. So angle B here is the same as angle D on the big one. And then they're saying that D and C correspond. So C is going to be triple. And then this right here would be triple on that one. So I'm going to redraw this second triangle out here so I can get it away from the big triangle. So I'm just going to draw a smaller version of the big triangle. And I'm going to orient it the same. So because the big triangle has these arc marks, I've got single, triple up here, and then double down here. I'm going to use that to name my triangle. So A is single. The triple is right here at D. And then the double is right here at B. Do I know any of the sides of the smaller triangle? Yeah, I know from A to D is 16. So I know that this side here is 16. I also know the perimeter of the big triangle. So the perimeter of the big triangle of ACD is equal to 31 plus 23 plus 16. So what does that equal? Add it up. What is it? 70. And I need to find the perimeter of the smaller triangle, which is ABD. That's equal to AB plus BD plus AB. And I do know AD is 16, so that's the only part of that that I know. Do I know any corresponding sides to the two triangles? Yes. Yeah, AC is 31 and AD is 16. So I'm going to set up my proportion, showing that I've got the perimeter, because I want to use perimeter of my proportion, that's why I gave you the theorem above. The perimeter of ACD is to the perimeter of ABD. So I'm going big triangle to small triangle as what is to what? What goes up here for my two corresponding sides? Where does AC go? Does it go top or bottom? Top, because it's big. So AC goes here. Its corresponding side on the small triangle is AB. So I'm going to fill in those. I'm going to let my perimeter here equal X for right now. So I'm going to plug in the numbers here, and I've got the perimeter of the big triangle is 70. The perimeter of my small triangle is X, and that AC is 31 and AD is 16. 31 and 16 cannot reduce, so I'm just going to have to cross multiply. So I've got X times 31, 31X equals, and then 7 times 16 is 1,120. Then divide by 31, and then X is equal to 31's prime. And so you could try to see if 31 goes into 1120. It doesn't. So you can either leave it as that fraction. Your book is going to say that it's 13, or I'm sorry, not even 13, 36.1, only because I think you're using a calculator. So I would prefer that, even though it doesn't mean a lot to us when it's perimeter, you could change it to its mixed number, which would be 36 and 36 and some fraction over 31. I'd have to divide it out to see what a remainder was before we got to 0.10. So either way. All right, so questions on that. So it's almost the same thing that we've been doing. We're just using our perimeter to help us in our ratios. So flip it. New theorem 7-8, and let me remind you again that you cannot use theorem numbers to describe a theorem. Some of you did that on your quiz also, and I counted it wrong because I don't know what the theorems are. I don't look them up. I don't memorize them. You're not supposed to either. So this one says if two triangles are similar, then the measures of the corresponding altitudes are proportional. So these altitudes here are proportional. So I put that BG is to EH, those are your altitudes, to any of the corresponding sides. So I just chose one of the sets of corresponding sides. AB is to DE here. So like perimeter, we can now use altitudes in our proportion. So example 2 says in the figure below, which we'll draw, QO and segment US are altitudes. Complete the following proportion. So let's draw our picture. So I'm drawing an obtuse triangle, and this is P, Q, and R. And then I'm drawing a smaller triangle, also obtuse. Let's assume my angles are the same. And this is T, this is V, and this is U. So here's the altitudes. So this point here for the big triangle is O, ran into T, sorry. And then this point here on the smaller triangle is S. And you are to finish the following proportion. The distance from Q to O is to the distance from U to S, as the distance from Q to R is to, and then there's a question mark. So using the theorem above, fill it in. So what goes here? QO is to US, those are your altitudes, as QR, here's QR. What side on the small one corresponds to QR? UV. So UV is here, or VU, doesn't matter which. So then we're going to find some missing sides. So if I gave you QR is 12, and that QO is 10, and US is 7, I want you to find UV. We're going to let that be X. So set up your proportion, which is right there for you, and solve it. Oh, UV, I put my UV in the wrong spot, didn't I? Oopsies, sorry. X goes there, doesn't it? How did I know I had something wrong? When you set up your proportion, was that UV? Nope. You guys are asleep, wake up. I probably had less sleep than you did. I'm nearly wide awake. So go ahead and solve that proportion. What'd you get? Yeah, don't go into long division. What'd you get? So if you solve, you should get, your cross products are 10x and 84, right? So then divide by 10. I don't want to see an answer as 84 over 10 because that's a reducible fraction. I saw that a lot this weekend when I graded your quizzes. So 2 goes into both 84 and 10, 42, and then 5 times respectively. That's what I want to see. I don't want to see a decimal. I thought I broke you of that habit. All right, so flip that. And then one more page. So Theorem 7.9 says if two triangles are similar, then the measures of the corresponding angle bisectors are proportional, so just like the altitude. And then Theorem 7.10 says that the medians are proportionate. So any of your special segments, and then the one that we're missing is the angle bisector. So here it is. So then this one says an angle bisector in a triangle separates the opposite side into segments that have the same ratio as the other two sides. So this one's slightly different. Because an angle bisector creates two triangles inside of a triangle. So the angle bisector is not necessarily proportional to the other angle bisector in the other triangle because they tend to be sides of those triangles. But what this is saying is the angle bisector separates the opposite side into segments that have the same ratio as the other two sides. So I've got a proportion here for you. AD, so here's your angle bisector right here. AD is one of the sides, it takes this whole big side of the triangle and breaks it into two pieces. So all this is saying is that AD is proportional to DB, and the other ratio that you can put over here would be one side from one triangle, one side from the other triangle. So these are the other two sides of the triangle. So I've got AC over BC. So I'm going from left to right here, so I have to go left to right here on the sides. So I cannot have this over this because that would be considered going diagonal. And that's it.